Hello all. So in this class, I will start our next unit, unit 3, that is geometry. See, in the first unit, some concept is remaining, but I am getting the confused because they have introduced the new concept, which type of question they will ask. So I will search that and I will explain that in the last. Okay. So till then, we will start our next unit. So our next unit is unit 3, that is geometry. And you studied this geometry in your 10th standard, up to 10th standard. Okay. So what is in the geometry, the most important thing is these lines, axis. Okay. Here we can call this is nothing but x-axis. Okay. And this is nothing but y-axis. And this is origin. Here we present it is by 0, 0. Origin means 0, 0. Okay. The center point. Now of this side we will get all positive integers 1, 2, 3, 4 and so on. In this side we will get all negative integer 1, minus 1, minus 2, minus 3, minus 4 and so on. Similarly, this is x dash, this is y dash. Similarly, for y axis, here we will get it is 1, 2, 3, 4 and so on. And here we will get it is minus 1, minus 2, minus 3, minus 4 and so on. Okay. So remember this. If you are having this line, in this side we are having positive, here negative. On the x-axis only. Here we are on the y-axis, this is negative, this is positive. Okay. Now if you consider this quadrant, this is called quadrant 1, quadrant 2, quadrant 2, quadrant 3, quadrant 4. So here you will get both value are positive. If you are considering x and y, see this is also positive, this is also positive. So you will get this value is positive. Here for and always we have to take first x-axis value, then y-axis value. Okay. In this quadrant, if you are taking x value, you will get first value is negative here and the y value is positive here. So in this quadrant, second quadrant, you will get first is negative, second is positive. If you see the third quadrant, for x value is again negative, and if you see the y value, again it is negative. So here you will get both values are negative only. And if you check this one, here we are having x is positive and y is negative. So you will get positive and negative. Okay, but always consider first x value. Okay, if you are writing in this way, this is called point on the lines. Okay, so we have to present it x and y. For example, if you are taking x is equal to 2 and 3, here we will get 2 and 3. But same element here, if you are taking here, you will get here minus 2 and 3. Because here it is negative, here it is positive. If you consider here, you will get minus 2 minus 3 because both are negative. And here you will get 2 and minus 3. First is positive, second is negative. Okay. So please remember this is very important. Okay, and this the coordinates of this fixed point are denoted, means these points are, okay, it is denoted by either a comma b, x comma y or h comma k. Okay, and this is called origin, center of the point, that is 0 comma 0, and it is called origin of the coordinate. Okay, now suppose if they said any line or any point lies on x-axis, any point lies on x-axis, means it replaces on x-axis. So the coordinates are given by x comma 0. If any point lies on x-axis, means we have to take the point from x only, but here y value is 0 because that lies means here. If you see, if this point lies here, what we will denote that by 2, comma 3, is it? Because from the x 2, from the y 3. But if any point lies here, if any point lies on x-axis, then how we will denote the value of x is 2, but what is the value of y? If you compare it is 0, so x comma 0. Similarly, if any point lies on y-axis, suppose if you are having point here, okay, if you are having any point here, we can write here value of y is 4, but what about the value of x? It is 0. So it is given by 0 comma 4. In general, 0 comma 1. Okay, so any point lies on x-axis, x comma 0. Any point lies on y-axis is 0 comma 1. Okay, remember these basic things because this is useful to solve the problem. Okay, so next we are having distance formula. First concept is distance formula. How to find Okay, plane means that this picture itself. Okay, if these two are any two points on this plane, then distance between these two points is given by, is denoted by AB. Distance between these two points is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Please remember this formula. Okay, distance between any two points AB is given by x2 minus x1 whole square plus y2 minus y1 whole square. What is x2, x1? Here it is given. This is x2, this is y2, this is x1, this is y1. Okay, write down that value, corresponding value. Solve this, take whatever you are having addition, subtraction, make that, take the square root, you will get that formula. Okay, but we have to measure this distance in units. So don't forget to write this units. Okay, if they ask the distance, we have to write the units. Okay, and similarly, suppose distance between any point A, x comma y, and the point origin, that is O of 0 comma 0. Origin is always denoted by O, and origin means both values are 0. Only remember that. Okay, so if you want the distance from the origin, distance between this point from the origin, then it is given by OA is equal to, remember these formulas, only x square plus y square. Only x square plus y square. Because see, if using this formula, suppose if you are denoting this is x1 y1 and this is x2 y2. Okay, then if you substitute in this formula, what do we get? x2 minus x1, that is 0 minus x1 whole square plus y2 value is 0. 0 minus y1 whole square. Okay, so this is equal to 0 minus x1 is minus x1 and minus x1 whole square is x1 square. Because as I said, if power is given, the term is always positive. Similarly, 0 minus y1 is minus y1. Minus y1 whole square is nothing but y1 square. Okay, so you will get the distance of any point from the origin is nothing but square root of x square plus y square. Okay, or x1 square plus y1 square. Remember these two formulas. They can ask the question for 2 marks. So let us see the questions. Examples depend on this. So first question is, find the distance of the following point. Find the distance. Find the distance of the following points. Find the distance of the following points from the origin. From the origin. They said from the origin means we have to use the second one formula. Means origin means here second point, one point is given, but second point is what? 0 comma 0. Okay. So in that first we are having 3 comma minus 4. From the find the distance from of the following points from the origin. Okay. So we are having 3 comma minus 4. So what we get? Using the formula, we are having this. Let us denote a given point as a of x1 comma y1, that is a of x1 comma y1 is equal to 3 comma minus 4. And we want the distance from the origin means we have to consider the second point is 0 comma 0. But directly I can write the formula, that is OA is equal to x1 square plus y1 square. This is the formula. Okay. Substitute the value of x1. What is x1? 3 square plus what is y1? Minus 4 square. So this 3 square 9 minus 4 square is 16. Okay. If you write down the 9 plus 16, you will get root 25. And root 25 is the perfect square. The value of root 25 is 5. So 5 units. Distance of A from the origin is 5 units. Okay. Only remember the formula. Similarly, we are having next point is A minus B, A plus B. Okay, second one, A minus B, A plus B. A minus B, A plus B. Okay, so again we can use the same formula. Let us denote it is A of x1 comma 5. So what we will get? OA is equal to square root of x1 square plus y1 square. Square root of what is x1? A minus B. So A minus B whole square plus what is y1? A plus B. So A plus B whole square. Okay. So we can expand this using A minus B, A plus B AB. Okay. Now if you see here minus 2AB plus 2AB get cancelled. So we remains with A square plus A square is nothing but 2A square. B square plus B square is nothing but 2B square. Okay. So what is the answer we are having? 2A square plus B square, or we can take 2 is common. So we remains with A square plus B square units. So the distance between these 2 points is 2A square plus B square units. Okay. This is one. Similarly, we are having many examples here. I will do that for the PDF. Okay. Next is find the distance between the 2 points. Find the distance between 2 points. This is from the origin. Okay. Then next we are having find the distance between 2 points. Find the distance between 2 points. Here the points are given. First one is 5 to 9, 5. 5 to 9, 5. Okay. Then let us denote the given. First A of x1, y1. Denote it. Here first write down the notation. 5, 2. And next B of x2, y2 is nothing but 9, 5. Okay. Then write down the formula. Then the distance between AB is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Is it? Substitute the value. Okay. What we are having x2 here 9 minus what is the corresponding x1 5. 9 minus 5 whole square plus what is the y2 we are having 5. y1 is 2 minus 2 whole square. So on this what is 9 minus 5? 4. So you will get 4 square plus 5 minus 2 is 3. So you will get 3 square. 4 square is nothing but 16. 3 square is 9. 16 plus 9 is root 25 and root 25 is a perfect square. So answer is 5 units. 5 units. So distance between A and B is given by 5 units. Okay, they can ask this question for 2 marks. Here they can ask for 2 marks. Similarly, we are having next one. 3, minus 5 and minus 2, 7. Okay. So again denote A of x1, y1 is 3, minus 5 and B of x2, y2 is minus 2, 7. Okay. So again write down the formula. If you write down the same formula, what will you get? x2 minus x1 whole square. What is x2? Minus 2. Next minus x1. So minus what is x1? 3. So minus 2 minus 3 whole square plus y2 minus y1. What is y2? 7 minus what is y1? Minus 5. So minus into minus you will get plus 5 whole square. Okay. Calculate this. Minus 2 minus 3 is minus 5 whole square. 7 plus 5 is 12 whole square. Okay. Minus 5 whole square is 25. 12 square is 144. So you will get this is nothing but 125 plus 144 root 169. 169. And root 169 is a perfect square and value is 13. So 13 units. So distance between these 2 points is nothing but 13 units. Okay. This is one example. Similarly, we are having next one A, B, A, minus B. Next one is many examples are there. Okay. Minus 1, minus 6, 4, minus 1. This is one. And the second one is A minus 2A and 3 minus 3A comma minus 3A comma A. Okay, we will solve these 2 examples. So for again denote x1 y1 minus 1 minus 6 4 minus 1. Okay, write down the formula, substitute the value. So what is the value? x2 minus x1. x2 is 4 minus x1 is minus 1 minus it is plus 1 plus y2 is minus 1 minus y1 is minus 6 plus 6 whole square. Square root of 4 plus 1 is 5. 5 square is 25 plus minus 1 plus 6 is again 5. 5 square is 25. That is nothing but root 50. We can expand 50 as 25 into 2 and 25 is a perfect square. So we can write 5 root 2 units. So distance between A and B is 5 root 2 units. I have written the second one, is it? Okay, write down here A minus 4A and 3A minus 3A minus, this is the second one, 3A minus A. So again here what we are having, x1 y1 is A comma minus 4A, x2 y2 is 3A comma minus A. So the distance between AB is what again, x2 minus x1 whole square plus y2 minus y1 whole square. What is x2 here? 3A. So 3A minus x1 is A whole square plus y2 is minus A minus y1 is minus 4A minus into minus it is plus 4A whole square. Okay. So this is square root of 3A minus A is 2A whole square and minus A plus 4A is 3A whole square. Okay. What is 2A whole square? 2 square is 4, A square is A square itself. 3 square is 9, A square is again A square. Okay, 9A square plus 4A square. 9 plus 4 is 13. 13A square. Okay, we can take A square and outside the root it becomes A only because we can write A square is nothing but 3 into A. So we can take one A outside. So A into root 30. A into root 30. Okay, units. A into root 30 units. Okay, this is the distance to how to find the distance of any two points. This is one. Next we are having okay, comma B, A comma minus B. Okay. Next point is collinearity of any two points or any three. Collinearity. Okay. So there is a question. Show that the following points are. Show that the following points are. Collinear. Show that the following points are collinear. Okay, there is a 5 marks question. Show that the following set of points are collinear. In that first we are having 4, 3, minus 2, 9 and 3, 4. 3 points are given. We have to show these 3 points are collinear to each other. Okay. So for that, first step is, okay, first denote every point by x1 y1, x2 y1, x3 y3. x1 y1 is 4, 3. D of x2 y2 is minus 2, 9 and C of x3 y3 is equal to 3, 4. Okay, these 3 points are given. First find the distance between each point. Okay, first distance between AB, distance between BC and distance between AC using the distance formula. Okay, then if any distance is the sum of other two distances, sum means addition. Okay, if any distance is sum of other two distance, then we can say these points are collinear to each other. So first we can find the distance between AB using x2 minus x1 formula. Okay, so here what is x2? Minus 2. Minus what is x1? 4. So minus 2 minus 4 whole square. Next here what is y1? y2 9 minus x1 is y1 is 3. 9 minus 3 whole square. Okay, minus 2 minus 4 is minus 6. Minus 6 whole square. 9 minus 3 is plus 6. So 6 minus 6 whole square is again 36 plus 36. Okay. So if you write down this 36 plus 36, you will get it is nothing. Wait a minute. Okay. 36 plus 36. So we will get the answer is 72. And we can write this is nothing but 36 into 2. And root 36 is a perfect square. So this is 6 root 2 units. Next find the distance between B and C. Next find the distance between between B and C. Okay. So if you compare the B and C, what we have to take? First this, then this. So 3 minus of minus plus 2 whole square plus 4 minus 9 whole square. Okay. So this is equal to 3 plus 2 is 5 square. 4 minus 9 is minus 5 whole square. So it is 25 plus 25. So we can write 25 plus 25 is 2 into 25 because it is nothing but root 50. Is it? So root 25 is a perfect square. So we can write 5 into root 2 units. This is the distance between B and C. Next, find the distance between A and C. Find the distance between, okay, we take consider C and E. C and E. Okay, so square root of. So now compare these two, C and E. So if you see, we are using like this BC. Similarly, we are here denoting it by CA. So first we have to consider this minus C. If you are considering AB, then what we will take? First B element, then A element. So similarly, we are considering CA. So we have. Wait a minute. If you are considering AB, we consider this element first minus this. Is it? Next, so similarly we are considering CA. So we will take or AC. Write down in any way, no problem. AC. Then you will get this minus this. Is it? Or this minus this. So here what we are having 4. So 4 minus 3 whole square plus 3 minus 4 whole square. Okay. So 4 minus 3 is minus 1 whole square plus 3 minus 4 minus 3. Okay. Minus 1 whole square plus 7. So you will get this is plus 1 whole square minus 1 whole square. 1 plus 1 is nothing but root 2. Okay, root 2 units. Now compare this all 3 units. Compare this all 3 units. So we are having AB is 6 root 2. We are having BC is 5 root 2 and CA is root 2 only. So we can write this is nothing but AB is equal to BC plus CA because AB is 6 root 2. BC is what? 5 root 2 plus CA is root 2. So 5 root 2 plus root 2. If you are taking root 2 is common, we remains with what? 5 plus 1. Here 1. But 5 plus 1 is nothing but 6. 6 root 2. See, we can write one distance is the sum of other two distances. If it is true, then we can say it is the collinear points. Okay, so their given set of points are collinear to each other. So they can ask the question for 5 marks. Okay, so we can solve the remaining examples in the next.